Okay, first things first. Let's go ahead and find the amplitude and period. So amplitude is equal to the absolute value of A. We're comparing this to standard form. Y is equal to A sine bx. Comparing it. So we can see that the amplitude then is going to be 1/3, which means we're shrinking. Those waves we're cutting in thirds now. Instead of the wave being one unit high, we're making those waves shrinking it because of the 1/3. So the amplitude is just 1/3. Smaller waves. Okay. Period now. Period's pi over 3. So we got period is 2 pi divided by absolute value of b, which in this case would be 2 pi over 6, absolute value is 6, which is 2 pi divided by 6, which is pi over 3. Very nice. Okay. So let's first make our axes accordingly. Before we find our 5 key points, let's make our x and y axis according to this. Okay, so here's my y-axis, x-axis. Amplitude is 1/3, right? I'll make this 1/3. This could be 2/3. Negative 1/3, negative 2/3. So we're going to have a shorter wave height. Okay. The period is pi over 3. So I'm going to make 4 tick marks. 1, 2, 3, 4. Here's pi over 3. That's the end of our period, the end of one cycle. We'll finish at pi over 3. Really. Now, what would be 1/4 the way of pi over 3? If you take pi over 3 and chop it into 4 pieces, what's the first piece? What would that be? So this is going to involve some fraction memory here. So 1/4, I'll do it over here on the bottom. 1/4 times pi over 3. 1/4 of the way of the period, look at it. That's going to be pi over 12, huh? So this first point would be pi over 12. What about 2/4 of pi over 3? Which is really 1/2, right? What's 1/2 of pi over 3? That'd be pi over 6, yeah? And then, let's look at 1/4 right here. Yikes. Pi over 12. This is 1/4, 2/4. This would be 3/4 of pi over 3. So I'm going to do the math down here at the bottom. 3/4 of pi over 3. That's going to be pi over 4, huh? Because the 3's cancel out. Yeah. Pi over 4. There's one cycle. All we're going to do is graph one cycle. So pi over 3, a complete cycle, is realized. Think about what pi over, how many radians that is as in an angle standard position. How many radians would that be? Pi over 3? We already know half a revolution would be pi. Pi over 3 would be about right here. Chop pi into 3 pieces. So if you had an angle in standard position, once the angle gets to right here, we were already going to complete one cycle instead of a whole revolution. So the wavelength is being smashed big time. You ever hear the wavelength? Radio waves, right? Amplitude and period, that's all part of gamma rays, radio waves, X-rays. They have these properties. So the wavelength is going to be smashed to where each cycle just takes pi over 3 radians to complete. Let's do it. So, amplitude period, five key points time, and we're done. It's not that hard. You just got to focus, pay attention. When you get the, it starts becoming second nature. You just start memorizing this stuff now. So 5 key points of a sine function. Are we sine or yeah, we're sine. So 5 key points now. All right. I think sine has 3 x-intercepts or 2. 3. Okay. The first one is 0, 0. It's always at 0, 0. That's the first one. So let me go. You plot that with me. Second one, Nunez, would be what?
1/2 the period and 0.
Okay, so 1/2 the period. So that's 1/2. Period is going to be pi over 6, huh? Zero. What's the third x-intercept, Linder?
Third x-intercept?
The third x-intercept for sine?
2 pi 0. I mean period 0.
The period 0. In this case, it'll be pi over 3. That's the period, 0. So let's plot these two in there. Pi over 6, 0, and then pi over 3, 0. Okay, so far so good. You guys are doing good. Maximum.
1/4 period amplitude.
So 1/4 the period would be pi over 12. Amplitude is 1/3. Pi over 12, 1/3. Okay. Small wave height and small wave length. We're condensing stuff. And then minimum. Hana, what's the minimum?
2 plus period
Negative amplitude. So 3/4 the period was pi over 4. And negative 1/3. Right here. There's a cycle. You can see it already. Make it curved. Don't make it pointed. Trigonometric functions are curved. There's one cycle. Shortened wavelength, shortened wave height. What do you guys think? No big deal. It'll start becoming second nature and more practice. Questions for me?
Can I see the one real quick?
Sure, sure. Max and minimum.
Do you remember those without looking at a paper?
Do I? Sometimes. On a good day, yeah. It's really, look at, just think period, chop it in 4 pieces. Sine is like this, cosine is like this.
Yeah, 2 maximums.
Right. It's all the just 2 maximums for the cosine, 1 for sine. It's just different the way they look. Let me show you. I like putting them together here. Let me erase this one. Let me graph the sine next to it. Watch. Look at cosine and sine next to each other, and you can see the different features. It looks kind of cool too. Looks like a 3D wave or something, you know? So here's cosine and sine right next to each other. Let's see, cosine's in red, two maximums, okay, right there. Whereas a sine only has one maximum, right there. Two x-intercepts for cosine, right there. And 3x intercepts for sine, right here. And then both have one minimum, if I'm not mistaken, right? Okay. Minimum for cosine, minimum for sine. For one cycle. Okay. You can start seeing the pattern here. You want to learn trig. All right, just do one on your own. Okay, just one on your own, and you can go and use the rest of the time for getting your grade up. Do one without me holding your hand. Okay, here we go. And raise your hand when you got it so I can check it. Do one without me holding your hand. Here we go. Y is so one cycle, graph one cycle. If you need more graphic, let me know, I got plenty. Just graph one cycle. Y is 2 cosine 3x. See if you can do that on your own. So first, amplitude and period, create your axes.